This time what we want to look at is finding the area between the y-axis and the curve. When we've got a curve that looks like that, now we can do it exactly the same way as we've done with the x-axis. If we're going the area to the y-axis though, what we're going to have to do is integrate with respect to y. So that's really the main thing that changes. That really means that we have to have a function in terms of y. It's no good having a function in terms of x. So in this example, it's a nice one that we've got x already in terms of y. If y is in terms of x to start off with, as we'll see with some other ones, we have to swap. We have to do a bit of algebra to swap it around. So x is in terms of y, which is nice. All we really need to do is go, okay, find where this function will go through the y-axis, and we can see it's minus 1 to 3. So our limits of integration will be minus 1 to 3, and that's going to be, and we're going to integrate it with respect to y. So we're going to have our function there. So if we changed that around and put it where above the x-axis and did it like it was a function there, and changed it to x, it'd be exactly the same. It doesn't change the integration or anything like that. We've just got to be making sure that anything to the right of the y-axis when we're doing respect to y would be positive. Anything over this side we find the area of is going to be negative. So again, we just integrate, do our substitution, and then do our calculations. Being really careful, you can see there's lots of negatives and positives going on there, so just be really careful with all those signs to get our correct areas. That's probably going to be the main problem in this one, where we can fall down and because we don't get those correct signs at times, so and get the wrong ones. So just be really careful with those. But what we've got to make sure is integrating with respect to y and our functions in terms of y. So we can see where that becomes a little bit problematic in this question here. So we've got the function y is equal to square root of x minus 1. We want to find the area between the curve there, the y-axis, so and the lines y is equal to 0, y is equal to 3. So this is the area we want to find. So we want to find the area back to the curve there, which is okay. We can go from 0 to 3 with dy, but what we don't want is y is equal to square root of x minus 1. What we need is a function in terms of y. So we just manipulate it. We square both sides. We get y squared is equal to x minus 1. Add 1 on both sides. So it becomes x is equal to y squared plus 1. So instead of having y in terms of x, we've got x in terms of y, which is what we need. We need to integrate a function in terms of y. The integration, once we've got to that point, that's probably it's all pretty easy from there. The harder manipulations is back in this part here and making sure we get that right. So we integrate, y squared goes to y cubed on 3, and 1 goes to y. We're going between 0 and 3, do our substitution, we get 12 units squared. So just make sure we manipulate to get a function y in terms of x in terms of y. So again, this one, we're going y is equal to x square root of x, so there's our curve there. And we want to sketch the curve from 0 to 4. So we've got that point there. So we see that's a point 42, and that's 0.11. So with the origin there, and we want to find the area bound by the curve, the y-axis. So there's our y-axis, and the abscissa. Now abscissa is just another word for y. So if you see that word abscissa, and even the computer's having problems reading that one, well, basically it just means the y values, which is 1 and 2 in this situation. So that's our area that we want there. So we're finding the area back to the curve again. There's our limits of integration. So we're going from 1 to 2, and we're going with respect to y. We're going to integrate with respect to y because we're going back to the y-axis this time instead of the x-axis. So we need to manipulate, and instead of y is equal to square root of x, we're going x is equal to y squared. So areas 1 to 2 of y squared, dy. We integrate there, substitute 2 and 1 in, and get our area that we require. So just be careful. We need to do this manipulation to get x in terms of y, to make sure when we integrate a function in terms of y, because we're going back to the y-axis, we're going to have a function in terms of y to do that.